What we've seen recently is quite a bit of uptake on the object storage side of things. Lots more customers are actually coming to Dell asking to learn more about what object storage is and what our DX product delivers, which is very exciting for us. The product is really starting to take off, and certainly we're seeing a lot of interest coming from the market. How many of you are familiar with object storage, at least in concept? Okay, great. That's excellent. I have to go and say, you know, we were talking about sales earlier. To Stephen's point, I mean, there really is quite a demand coming from our sales teams around doing unique things with the storage products that are out there. So what we are seeing in the field, and I've been out in the field talking to customers, I must have talked to at least 100 by now. The sales teams very much see the opportunity for storage, and certainly around object storage, and they are understanding the right places to position this. So there's two primary use cases for object storage that we've really been encountering and seeing a lot of uptake. One is around archive. Object storage really hit the market in 2002 with Centera. Object storage, essentially, they called it CAS. That was all built around archiving. Today what we've seen is a convergence now around object storage and the unique capabilities of it that's enabling it to be a nice fit for cloud storage infrastructure. A lot of that has to do with its scaling. So the DX is a clustered storage architecture. And what we're doing is we're clustering on standard Dell x86 server platforms. To get started with the DX, there's a base configuration that you have. And that's 3 nodes to get started. The first one's called the cluster services node, and then you need to have, at a minimum, 2 storage nodes. And I don't know if I'm writing big enough. Can you guys see this, or do you want it bigger? Okay. You have to have at least 2 storage nodes to complete the cluster, and then you add as many as you need to handle whatever capacity requirements you might have. Today we have 2 flavors of nodes. One is a 2U12 drive storage node. It's based on our R510 platform. We'll be moving to our 12G platform later this year. That's at 12 drives. 3 terabyte drives supported, so you get 36 terabytes per node. In a base cluster to get started, that's going to give you 72 terabytes max. And then you can scale out. The upper limit, theoretical limit on the DX is 1.6 exabytes in a single cluster. Yeah, it's quite large. We haven't grown one that big yet, but I'm looking for that first customer.
But if somebody has the PO, you'll do it.
Absolutely. Take it from. So the important thing to note about this is it's all HTTP is the primary access mechanism to it. So you have HTTP as the native interface to the DX. Very nice, gives it that cloud-like flavor, very different from the heavyweight API that Centera had put in place and a lot of the other storage products that are out there. The nodes, essentially what the software is doing is it is virtualizing all of the storage within a node, and then across all the nodes presenting a single scalable file, or not file system, but object store. So all of the space is addressable. So you can scale very nicely. I call it multi-dimensional scaling, so we can scale up in terms of capacity to the 1.6 exabytes. We can scale out in terms of number of objects, object count. What the DX does is when it stores an object in, it creates a 128-bit unique identifier, and that unique identifier is essentially your address, your file handle, that file back. So you can literally get a 128-bit flat address space, so it scales in that dimension as well. It also scales in performance very nicely. As you add additional nodes to the cluster, you're adding additional CPU power. So you are improving your performance every time you add an additional node to it. Keeps in line with the Dell direction around pure scaling architecture. It's important to note that a lot of people, when they look at object stores, and especially archiving, they think of very low performance, not designed for high performance. Whereas in the DX, you can get very nice performance. We just ran a test with large objects for a particular Web 2.0 customer. And we were running 200 gigabyte objects in there, and we were getting writes between 13 and 14 gigabytes per second, and reads coming out at up to 16 gigabytes per second. So it was demonstrating very high performance in that kind of a
How many nodes?
40 nodes. They were 2U12 drive, 3 terabyte drive, so it was around 1.4 petabytes that we were running that test against. I don't know how many clients we had writing to it.
So how is the data protected in the storage? Is it RAID 1 cross nodes? Is that?
The way that data is protected is through replication today. So when you write an object in, it's going to get stored on one node, and then an exact replica is going to be made on another node within the cluster. So we're protecting data through replication. The objective of that, and this goes to the heritage of it being an archive, is to keep the objects intact, not split them up like you get in the file system where you're blocking files and essentially striking them across disks. Is to keep the data whole and together. And the reason for it is that if a node or a drive fails, you still have access to the replica, the other replica in the system. And then if that event were to happen, the cluster will participate in creating the additional replicas that need to be maintained within the system.
Is the storage in a node RAID 5 protected or anything like that? No?
No. And so when you store it, it's a fairly unique architecture in terms of how.
It's not. I mean, it's not that we can't. I mean, you
just
could use an
wouldn't.
RBOD underneath there, but there's no reason to do that. It's just cost.
Yeah, it wasn't the design objective to use RAID within it, but yeah, you can certainly do it.
You don't
I
have to.
can set a policy to have more than 2 copies, right?
Yes.
Yes.
Yes. So
Even
you
7,
can increase
8.
the resilience level based on policies.
It's up to your potential or your preference around protection. So you can go, right now, the minimum is set for 2, maximum of 16. We are,
The advantage is you can
so you can set that, and you can set that policy on an object by object basis. So one object could have a policy of 2 replicas, another may have a policy of 4 replicas. It really depends on how the application is writing that data out and submitting metadata with it.
And within a node, all the storage has to be the same. So if I had 2 terabyte drives, it don't have to be 2 terabytes, or
No.
do each of the nodes have to be the same size?
No. You could start with a base cluster that includes 2 1U4 drive nodes. You can add 2U12 drive nodes to it, and it's going to take advantage of that additional capacity. You can intermix nodes.
So the theoretical maximum size of an object is the size of a node.
Actually, it's the object limitation today is 20% of the size of the drive, so 600 gigabytes today. We have a feature coming out later this year that's called disk chunking, where what we will do is we will spread larger objects across disks within the system. The reason for the limitation right now is because we keep all of the data together as one contiguous object. So what happens is, when you write that file in, you're writing it starting, you get a starting block, and it just writes it contiguously. So not like the file system where it's blocking the data. And then the next write that comes in starts at the very tail end of that, writes that size object. So it can be very efficient on disk. If you write a 1K object in, it's going to use 1K of space. It's not going to waste 3K of a 4K block. So it's not using blocks in it.
But single object read-write performance is limited to the throughput of a single drive.
Yes.
And a single node.
No, a single node.
Single node.
And a single drive.
Because
No,
you-
he's
No,
right.
an object-
An object has to fit on a single drive.
Yeah. Yep. That's the limitation right now.
So when you said object is limited to 20% of the drive size today, if you've got different size drives in your complex, is it based on the least minimum size? Is that so? If I
Yeah.
have 1 terabyte, 2 terabyte, 3 terabyte drives, it's roughly 200 gig.
Right. Well, that's 200 gig for the 1 terabyte drive node. If you have 3 terabyte
But is the
nodes,
CSS...
But if I have a mixed configuration of 1, 2, and 3 terabyte drives in 3 different storage nodes, let's say, then my object's limited to the smallest drive.
no. The algorithm is going to calculate what what size object can go into an individual node.
But in that configuration, you gotta have at least 2 copies, so you're gonna have one on 3 terabytes and one on 2 terabytes at a maximum.
So it'd be 20% of 2 terabytes.
So if you have a file bigger than 20% of the disk of the smallest member, it just wouldn't copy to that member. or
That's
what?
right.
It would copy to the other members,
Right.
of which it can.
Right.
Right.
And if you have a node that has 3 terabyte drives and another node that has 2 terabyte drives, it will make that copy on the same node. It'll try to make it on the other one, but because of the disk limitation, it won't. It'll make it on a different drive within that same node.
Okay, so for very large, yeah,
So you would have.
it's just a planning issue.
Yeah.
Right.
If you buy nodes with big disks, you buy at least 2 of them.
Right. Well, the truth is, you don't buy this with 3 nodes, you buy this with 10.
Of course.
Yeah. Well, I've sold this thing as low as 4 terabytes in a single cluster. And that's because, we have customers who have compliance requirements. They don't have a lot of data, but they have compliance.
The regulatory side, yeah.
Yes. And then we've sold cluster at 3 petabytes. They have both compliance and retention needs as well as large-scale capacity requirements. The other thing that's unique about the DX is the way that it stores metadata and file data. So object stores, the value in that is that you can add additional metadata, more descriptive metadata to an object. So what the DX does is it stores metadata and the file data together in this contiguous disk space. So the metadata lives with the file data for its entire life cycle. There's no separate metadata server. There's no lookups that you need to have. There's no access or control nodes in the DX. This cluster services node is really providing management and administration. It's not in the data path. If it were to fail, your applications would still be able to read and write to and from the storage nodes directly. So it's another unique capability of the DX is keeping all that. In the metadata, we keep the unique identifier. The unique identifier is actually kept in memory, so it can be very fast in terms of how fast it can move. It can identify what node needs to serve a request up. So that's how we scale the space. For instance, if you're coming in and you're asking for a particular object with a unique identifier, and it's not on the first node you hit, it's going to do an HTTP redirect to the node that does have it. What it's doing is when it hits that node, if it notices it doesn't have it in memory, which is very fast, it's going to issue a bid request. And that bid request is saying, I've got a request for an object, who has it? The nodes that have that object will respond with their bids. The lowest bid is going to win. It'll select the lowest bid in that. So it's going to optimize that read request and send it to the node that can optimally service it.
Is the bid a random number, or is it based on some I/O loading or something like that?
Yeah, it's actually, the bid comes back that includes information about, how busy the node is and how much capacity it has on it. So it's weighing which node can actually service that read faster. And the writes are done similarly. If the write comes in and hits a node that's busy, it's going to redirect that to the least busy node in there. And that's all done with standard HTTP redirects. The metadata is, that area that gives you a number of capabilities around intelligence. So if you think about archiving and cloud, their requirements are fairly similar across. Massive scale, ease of use. They want to have policy-based data management and replication.
What entity assigns the object ID?
The DX assigns the object ID and returns that back to
The storage node?
Yeah.
How can you guarantee it's unique?
It's a 128-bit random number generator that creates that.
And then it checks it to make sure that it hasn't randomly
But
created.
do you guarantee no collisions? I mean, it's not just a SHA calculation.
No, it's not a SHA calculation. It's a 128-bit random number generator. And we're continuously running that random number generator and checking for collisions.
Okay, so there is a check.
So you can have two separate objects that resolve to the same SHA-256 hash, and you will not have a data integrity problem,
Well,
right?
No.
Shouldn't work.
Well, you,
No.
if two separate objects that are uniquely different and they hash to the same digest,
Yeah.
then you potentially could have a problem, right? But different than like Centera, which used its MD5 hash as its address, and you can encounter that, but so the DX doesn't use a hash algorithm as both its address as well as its integrity check or authenticity check.
It does or it doesn't?
It doesn't.
Okay.
Yeah, so
You
what
know,
this
how do
means is
we-
that a hash collision is less impactful than you would think it would be.
But a
in
random
typical
number
object
collision
storage.
is.
Yeah, what if the random number generator hits two of the same in one array's lifetime?
And each storage node is doing its own 128-bit random number generation?
Yes.
But you said it checks to make sure there's no collisions on the handle.
Well,
You said it doesn't check.
It doesn't check.
Does
What
not
we're
check.
doing is we're running a test, we continuously run the random number generator and we check for any collisions. And then we haven't had one in the 6 years that it's been running.
But when you do, what's going to happen?
So empirically,
It's gonna assign that unique
Yeah, for custom
identifier
issues.
to the object and it's going to overwrite what
So there
was
really
there.
is no central metadata services here.
And what are you using as a random number generator?
It's a unique IP out of Coringo.
A unique IP?
Yeah, they're.
Oh, unique IP.
Yeah.
Okay, I'm like, and a unique IP, I'm like, yes, it's IP address, you know.
They have their own IPv6 range.
Oh, that's fine.
I think
Yeah, so that'd be fine.
I think 128 bits is like more atoms than, more hydrogen atoms, is a larger number than the number of hydrogen atoms in the universe.
Yeah, you know.
Right.
we're-
I mean,
we're
it's a
worried-
really big
We're worrying
number.
about those collisions, but we're more likely to be struck by an asteroid before we leave Dell.
Thank God.
Right.
Oh my. That's why they got the flying stack.
careful what you wish for, Howard.
So the unique identifier is a random number. Then the other thing that the DX does is it actually does a hash digest on each file that's stored. And it will store that hash digest as a digital signature as a part of the metadata. And what it uses that hash for is that there's a health processor that runs on every node in the cluster. And that health processor is walking through every object that's out there, and it will regenerate that hash digest and compare the two to what was originally generated when the object was stored, and do a comparison. If it realizes that there's been some silent corruption or that hash digest doesn't match, it's going to throw that object away and create a new replica from the known good replica still in the cluster.
Okay. So
So
it is
this-
going to do something about it.
Yeah, so I mean, and then the other thing that it does with the hash digest, it has what's called a content integrity seal, where the application can request a hash digest back, its own signature back, that the application can hold on to so it can validate it upon retrieval as well. And that hash digest can be assigned by the application, so you could ask for a SHA-1, a SHA-256, RIPE-ND, it depends on what the application wants.
There's a question that came in from Twitter. Do you guys support geo-replication services across local WAN distances and things of that nature?
Yes, yeah.
So a storage node could be across, I'm sorry, another cluster? How does this work? Is the storage node split across, or is it cluster, multiple clusters here?
It's multiple clusters across distance. So you'd have another DX instance over here. Okay, and it's going to replicate across the wide area. You know, you can pause it out here. It's going to do its replication over distance using what's called the content router. The content router is a software feature that sits on the CSN. We just abbreviate it as content router, CR. And what the content router is it's a publisher-subscriber model. And what you do with the content router is you define policies based on metadata elements and values for the objects. So you could define a policy that says, for all objects that equal JPEG, I want to replicate to the far distance. What happens is that the content
I'm
router-
sorry, you said there's policies on the cluster manager that utilize the metadata that's sitting on the storage node?
Yes.
And this is all tied together through this 128-bit random object identifier?
Yes.
So there is metadata on the cluster manager,
No, actually, there's not.
but the policy information is metadata.
Well, yeah, so you're right. The policies reside at the content router level. And what the content router is doing is it's monitoring every object coming in, and it's looking at it's filtering the metadata to look for a hit. So for instance, if you have the policy of all content of type JPEG, what it's going to do, it's going to find that object, it's going to see that metadata, and it's going to start building a list. And what it does is it builds a list of unique identifiers that is a part of the publisher, and then the subscriber is subscribing to that list and identifying what needs to be replicated across distance.
Is that also a one-to-many, many-to-one
Yes.
kind of thing?
Yes.
And that policy the policies of that having an amount of copies on an amount of other sites is not on a cluster base, it's on a selection of objects, or on a type of objects.
Yes.
Where do you set the policy on? How low can you go with the policy?
Well, the policy is based on metadata within the object. So you can get down to the object level in terms of the policy that you want to set. So it could be a group of objects that match that particular policy. It might even only be one object that matches that policy. It may be one object every other week that hits that policy and gets replicated or distributed. So you can do a one-to-many kind of a distribution model where you might want to push data out. One of our customers, I can't mention the name of them, that's a very prestigious university in the UK. They're actually building what they consider their own private cloud. What they're doing is they're putting clusters, DX clusters across the world in various locations. So Asia, North America, South America, Africa, Middle East. And what they're going to do is they're going to publish data from their primary site to all these other sites and then allow those sites to use the data locally. What they're doing is they're actually integrating with both SharePoint and Alfresco to provide the user access to the data and the sharing of the data. And they're injecting additional metadata in there so that they can adhere to copyrights. So one of the things that they'll be doing is replicating data based on the copyright information that's held in metadata. And the reason for that is some countries don't have the rights to use some of the content that's being generated at the primary site. And so what they want to be able to do is distribute that copyrighted material to only those sites that are allowed to see it. We're in the midst of deploying and rolling that out now. It's actually a pretty cool implementation that at some point we'll have a use case built up and written around it so we can talk more freely about that particular customer. Now that's how we do replication over distance.
So how does the cluster manager monitor object creation in this fashion? I mean, so it's an object creation. It's going to check to see what policies are associated with it and whether it has to be pushed out to these other clusters. Is that?
Yeah, I mean it's really a very simple process. As objects come in, the content router is seeing every object that comes in, and it's looking at the metadata header on it, and then it's determining whether or not there's an element within that matches a policy, and then it just builds a list of unique identifiers. So all it's storing is essentially the unique identifiers.
So an object associated with that policy, and then it's going to tell the storage node to go push that data to the other cluster? Or?
No, actually, this is subscribing to that list,
Uh-huh.
and the subscribing is going to say, I need to replicate everything here, and then the storage nodes here are going to actually do a poll
Oh, okay.
and replicate across the distance. There's also replication, so we replicate internally already. We've also deployed DX in campus-wide environments where they're running on a campus area network, so they have a DX in one building. And then they're putting just storage nodes in another building. And what happens is, if you have a policy that says, I need 2 replicas, what it'll do is the object comes in here and it'll get stored here, and then the replica is made in the other building. So it's managing, it looks like one single cluster, but they're distributed across. And if you have enough bandwidth between your distributed sites that you can make it look like it's on the same local area network or that kind of speed, you can distribute that way.
But that other site has to have a CR load, right?
No, the other side, well, it doesn't have to. You could just have storage nodes out here, and it will replicate and put them on this storage node, because essentially, it looks like one cluster, so you don't have to have a content router to do it. The content router is really for distributed replication. And what I like about the content router is it opens the door for more kinds of things that you might want to do with data. So we integrated the Ocarina technology into the DX. And when I say integrated, we created a new storage node called the storage compression node, which includes the Ocarina technology. And what we did is we built a subscriber on the storage compression node. So what it's doing is it's actually there are policies that are set at the content router for all objects that need to be compressed. It's subscribing to that list, and then what it will do is it will find those unique identifiers, pull that out of the DX, run it through its compressions, and put it back in. You get kind of 2 levels of intelligence. You can tell it when you want objects to be, when and what kinds of objects you want to be compressing. The Ocarina technology will take and leverage the best compression engine available to compress that type of object that's coming in. So this is another way that we're leveraging the content router. We also have an integration with an index search engine company that has written their own subscriber to the content router. And what it's doing is it's finding every new object that's coming in, and it's getting those list of IDs, going out and indexing the metadata as well as the full content of the objects, and storing that in its index so you can do search across the cluster.
Has there been thought to do AV with the content router? Like a offloaded scanning for your SIPs?
Yes.
SMB?
Yes, we've had conversation. We haven't actually implemented it, but it will be the same kind of a process where you might put an antivirus down here. It's what I call a content pipeline. I mean, you may set a policy that says at a certain state or a certain date you want to pull that out. Maybe you want to run it through the antivirus first and clean that, then run it through the content router or the compression node, and then place it back in. I mean, you could put together a whole policy around a pipeline of activities that you might want to conduct on it. Or if you're just doing the antivirus, you could do that as well. We've actually talked to some in the media entertainment space about doing it around transcoding. Yeah. So you can pull data out, transcode it, keep a proxy in here, and let the high fidelity or the high def version of the video go to the deep archive. So it opens the door to a lot of things, and this is why the customers that we have today cross industries, from financial services, oil and gas, government, library, digital libraries, and cloud storage. We have a couple of email archive storage customers that are using the DX or working through their deployments now to use DX as their back-end infrastructure. So you see a lot of the capabilities that archivists want around their data, as well as what the cloud storage vendors want. We have the digital library is very interesting. I was just down in Stanford talking with a customer down there. We have a customer at the University of Illinois that has actually written a connector between Fedora Commons, Medusa project, and Fedora, if you're not familiar with it, is a very well-known digital library management software, open source. They've written a connector to it, and they're using that for their digital library. And one of the things that they liked about the DX was the way that it stores the metadata and the file data together, so they can ensure the longevity of the data and the metadata. But they're also looking at ingesting additional metadata along with it, which would be Dublin Core elements. If you're familiar with the Dublin Core metadata schema.
So in this compression node approach, you take the object and metadata, you compress it, you push it back to the storage node. Are you creating a new object at that point, or you're replacing the old object with the new compressed version of that? And now when somebody comes in and says, I want that object, do you have to pass it through the compression node to get decompressed?
Today you do, yeah. One of the things we're working towards is to put the actual compression decompression engines as a part of the software developer's kit. So you could do decompression on the client side. We didn't implement that when we first came out with the compression node, but it is something that we're working towards.
It really should be positioned as a tiering functionality, right? There is a performance impact of getting that extra economic boost.
But why wouldn't you put the decompression in the storage nodes and just decompress the object on the fly? You can still compress it, you know?
Because the first implementation was about fast time to market and easy standalone.
No, I understand where you're at today. My question is, if you're going to do something in the future, why put
there's two options there. One is to run it in the client library. If someone's already coding to the API, why not let them, because the decoder, the decompressor is actually very lightweight.
Yeah, so why not do it on the storage node?
There was an
That's the
architectural
second option.
decision.
And so it's probably premature to figure out what the roadmap is here.
Whatever.
Yes, we agree with you, that would be a good idea. That makes a little bit more surgery though, so that would be a subsequent release.
It's an architectural decision of where to put the decompression. You could do that. You're modifying the architecture of the underlying object store. The customer that I had in recently who bought 3 petabytes of it, basically their biggest requirement was don't do anything more inside the storage cluster. Keep that pristine. Their comments to me were, what we liked about it was a perfect fit for our use case, and we liked the simplicity and elegance of it because they're not looking to do the decompression and compression on the storage nodes themselves. They just want the storage capability. The decompression and compression. What we counsel is, compress things that you think are not going to get access. So put a policy in where you're going to compress after 60 days in the archive or 90 days when you're pretty confident that that's deep archive now and it's not going to get touched. We'll definitely be taking a look at other architectural implementations, but those are comments that we've had. From my perspective, having led engineering teams before, I'd like to see us keep this pristine. It is a very solid product. It does what it does. There are things that we could do to put compression and decompression within the storage nodes and add additional capabilities there, but now you're starting to impact potential performance of the storage nodes. You've got to cluster all of that stuff together. It's something where more deeper discussion needs to happen around design and architecture and what the potential impacts are.
That's after it's get acquired. That's for after the acquisition.
I can't comment on anything about that. So we've got that storage
We've got
node.
about 3 minutes and we need to wrap it up.
Okay.
I thought it was acquired.
So the customer who's doing the 3 petabytes, their clusters are actually going to be 2 clusters, 1.5 petabytes each. They came back and they said, we want to just store 1 replica. I was like, oh, you're not protecting your data. Well, they're basically making a decision through their application because they're doing a native integration to it. And they're saying some data is more important to me than others. So they're fine with the replica and they're fine if it actually gets lost. So what they're doing is they're injecting into the metadata how many replicas should be kept. And so they're going to have some data that has only 1 replica, meaning that it doesn't have a second replica for protection, and some data that's going to have 2 replicas. So it's a nice use case.
So the replication is post-object deposit? So the object gets deposited into a storage node, and then the metadata says, okay, I want to replicate it to another storage node?
Yeah, it'll get replicated. Yeah, you can do it.
It doesn't get replicated until after the object is, I would say closed, but that's not an object term, right?
Yeah, so there's two methods you can do. You can do, let the cluster do the replication after it's been written in, or you can ask for a replicate on write, which means you're gonna wait a little bit longer until that second object has been written, before you get the all goods from the cluster.
But either way, it lands in one storage node, then gets replicated to another. The difference is
You're not writing
when you
twice.
act.
Right, right.
Yeah, but in that case, the data is not rate protected on the storage node.
No,
No, but that's
Right.
that's the same for everybody, isn't it?
No, it's
should be
not.
writing it twice
No, it's
at the same
not.
time.
I don't mean everybody in terms of storage arrays. I mean everybody who's doing object stores tend to do it the same way.
Either that or they use erasure codes. You rarely see object replication and RAID together.
Yeah, so, Mike
I see
mentioned-
rain a lot.
No, actually, you do.
Yeah, actually, you do.
You do.
Well, facility disaster protection uses replication. Failure resilience against component failure requires either Reed Solomon or local computer, right? I mean, there's two different reliability domains you're trying to solve for.
Yeah, it's all based on how you want to define your fault tolerance and availability.
Yeah. And since it's normally an archive application, it's not the only, when I put the copy into this object store, it's not the only copy. And if I tell the object store.
Momentarily, yes. Within milliseconds, no.
No, but if I tell it replicate between the two nodes before you act, and I don't delete the copy from the source before I archive it till I get the NAC.
Yeah, of course.
So those milliseconds, it's just, it's not like, it's rare that you're creating data in an object store.
I didn't realize object storage was so controversial, because everyone's always told me that it's so boring. Every time I bring it up when I say this is my favorite technology. Yeah, this is like the opposite, so I think.
This isn't boring.
Object storage is not a
No,
side
I know that
project,
it's not, I love it, this is my favorite technology.
and it's a very cool technology.
I did not realize it was so
Great leads that they're
controversial.
talking about.
It's very interesting.
So, I mean, this is the reason I left Coringo and came to Dell, was it's gonna take a brand to really build this market, which, my expectation is gonna be, it's the next new product category in storage. And Dell has a great opportunity to basically open the doors to this marketplace, and we're starting to see that now. The amount of activity we've got going on around the DX is significant. I mean, I'm running around to customers, to new deployments, various things. It's really exciting time, just based on the amount of activity, the new requirements that are coming in, the requests from customers. We're going to continue to enhance the product. Mike mentioned earlier about erasure encoding. That is something that's on the roadmap. We are going to be delivering erasure coding probably this year, and we're excited about that. It gives us hits some of the requirements that we've heard from various customers in the Web 2.0 and cloud storage space. What's nice about that is you'll be able to define a erasure code scheme on a per object level if you wanted to. And then, it's also going to be set so that we can define, whether an object is too small where erasure encoding doesn't really make sense. And so we may replicate in that instance. So I can't talk more about what the details are of the implementation of it, but it is something that's coming and gives us the ability to, reduce the footprint, because now we're not taking up twice as much storage for, usable versus raw. It'll give us more of that capability, and then allow us to slice data across data centers, so that we can do a protection scheme across multiple data centers and be able to recover from failures of a whole data center, individual nodes in the data center, from across all the various sites. So that's something that
Is it gonna be Reed Solomon or something more advanced?
I can't really talk about it. It'll be similar. It'll be a Reed Solomon like algorithm.
There are different approaches. I mean, tornado code, Reed Solomon. I mean, it's all about M, and data integrity for failure resilience. And that's sort of like details of implementation. I mean, they're getting to be pretty well understood at this point.
You can do better than Reed Solomon, significantly.
Exactly. Well, exactly. I think Reed Solomon is tried and trusted, but I think there are particularly more CPU lightweight codes out there like Tornado. We'll see. We'll see what happens.
Yeah. Next time we do this briefing, I have more detail on that that I can actually share.
And you don't mind talking on Twitter, right?
Oh, no.
You might want to give them your Twitter.
Oh, they have it.
It's on the
It's
paper.
on the papers.
Yep. Praveen's the only one missing.
Yeah, I should put it in mind.
Well, we got some sort of-
Great, thanks. Feel free to ask me questions on Twitter. All right.